First light. The outburst begins.
First light. The outburst begins. So how did this all start? It began quietly. On September 12, 2025, a comet designated C-2025 R2 Swan made its closest approach to the Sun, a point known as perihelion. At first, everything seemed normal. It was a faint object, gradually brightening as expected, with a magnitude hovering around 7.4. But comets are unpredictable. 2 weeks later, on September 26th, amateur astronomers in Japan and Australia noticed something extraordinary. The comet's brightness suddenly surged, jumping by nearly a full magnitude to 5.7. This pushed Swan into naked-eye territory for anyone under dark skies. That's not just a minor flicker, it's a sign of a violent event. This kind of outburst points directly to the comet's nucleus, a frozen core of ice, dust, and rock. As it swung away from the Sun, intense solar heating likely caused pockets of super volatile ices, like frozen carbon monoxide and carbon dioxide, to sublimate and burst through the crust. This process, known as cryovolcanism, flung tons of dust and ice into space, dramatically swelling the cloud of gas and dust around the nucleus, called the coma. Cometary scientist Dr. Casey Lease of the Johns Hopkins Applied Physics Laboratory notes that such events provide invaluable data on the pristine, deep-frozen materials from the birth of our solar system. The event put the entire astronomical community on alert, transforming Swan from a routine object into a live and unpredictable scientific experiment.